I'm Anil Kumar. We are exploring area under a curve, and in this particular video we'll look into a trigonometric function. Now the question here is, find area of the function f of x equals to minus sine x from x equals to minus pi to x equals to 0. So that's the question for you, and the concept here is that if f is any antiderivative of the positive function f, the area under y equals to f of x from a to b is f of b minus f of a. So that is the concept, right? So let's look into it. So we have the function which is f of x equals to minus sine x, and we are interested in finding the area from minus pi to 0. So first thing is we have to check whether it is positive or not, right? So that is very important to check. So let's kind of sketch it. Okay, so we have what? We have minus sine x, correct? So minus sine x will be okay, so let me just sketch one function and then we'll see what minus sine x is. Okay, so let me just use a colored pen. So I'm just drawing a sine function kind of like this, and then we'll see what we have, right? Now minus sine x really means that if you have a sine function, okay, let's we are saying this is our f of x, correct? And that is x for us. Now let me show you how I got this. Okay, so let's do it again. So what we are going to do here is that we'll sketch sine x first, right? So we'll sketch sine x first. Okay, this is within the interval of our interest, right? So this is 0 and this is sine x function, you know. So sine x is 0, it goes to this, and that is how it is, correct? So we have sketched from minus pi to pi, correct? So that is how a sine function looks. But if I have minus sine x, it is reflected on x-axis, right? So it is reflect on x-axis. So what you get is this, perfect. So that is what you get, and as clearly you can see within this interval of minus pi to 0, which we are talking about, this interval, this function is positive, right? This function is positive, right? That is. So now we can apply our formula and find the result, right? That's the whole idea. So this is positive between these two. Is that okay? Where of course this will be 1, this is minus 1. Okay, good. So now the first step here is to find the antiderivative. So what is antiderivative of minus sine x? Well, let me write cos x first. And then what is the derivative of cos x? It is minus sine x. So that is perfect, right? That's perfect. So we'll use cos x as antiderivative. We are choosing c, the constant, to be 0. The idea is when we do this difference, that c cancels off. So I'm repeating this since it is very important to understand. Okay, so now the area is clear. So the area now between this limit is from minus pi to, I should have written 0, I'm sorry, from b to a. So f of b to f of a, so f of minus pi. That is what the area is for this antiderivative. Okay, so basically what is cos 0? So we have cos of 0 degrees, radians I should write, I'm sorry, minus. Now minus of this is cos of minus pi, correct? Okay, now what is cos of 0? Cos of 0, as you know, is 1, right? So it is 1. And what is cos of minus pi? Cos of minus pi is 0. So it is 0, right? So cos function starts like this, right? So it goes from here to, let's sketch the cos function. Let's do it. So cos function is kind of like this. Cos function starts like this and goes like this. So I made a mistake here. I'm just showing you how. Okay, so let's look into it instead of rushing. Okay, so that is the cos function. That is the cos function. Okay, red is good. I need to make a correction. Okay, So where this is pi and that is 2 pi. So what is cos of pi equals to? It is minus 1, okay? Not 0. So cos of pi is minus 1. Well, it is minus pi. We also know one thing, that it is symmetric, right? So even symmetry. So let me also give you one more formula here. Cos of minus theta equals to cos theta. It does make sense to you. We know it is even function, right? Even function. So many things to learn as we move on. So strictly speaking, I did make a mistake and took this opportunity to explore it further. So at times, well, you can always use your calculator, put it in radians to calculate, or you can sketch your graph and then see for yourself that cos of pi is minus 1. So we made this correction. Very good. So now what we get here is area as 1 plus 1, which is 2. So our answer is 2 unit square. We don't know what units we're talking about. So it's safe and sound to just put unit square as the units, right? Area. Perfect. So that is how you should be doing it. So what we learn here is that first step is to find antiderivative of the function, and then difference in their value for the given limit gives us the answer. That's so simple as that. I'm Anil Kumar, and I hope with these examples the foundation has been laid. We'll now move on to definite integrals and then see how to find area under the curve. All the best.